Okay, so this is the video for Friday. I did come up with some questions I found that would pertain to the intermediate value theorem without the mean value theorem. So let's look at these, how these work. And they're pretty simple if you see the idea. Okay, so let's see, make sure we get it, right? Suppose you know f of 1 is -2 and f of 5 is 4. You don't have to do this. What I usually do is I draw a quick graph of that. You don't have to do that. F of 1 is -2 and f of 5 is 4. Now, this is what I usually do. I'm not kidding. Just connect. Okay. Okay. Now I apologize. I didn't put up the numbers here. Oops. 0, 7, 2, -5, 1. Okay, now, if I know f of 1 is -2, and I know f of 5 is 4, which of these 5 must be true? Which of these 5 must be true? Well, here's the deal. Here's all you do. You literally look at the -2 and 4. Can you go from -2 to 4 without passing through 0? No, you can't. So this one has to be true. Yay. Now, here's the thing. Can you go from -2 to 4 without going through 7? No, 7's way up here. Now, that's not to say that you couldn't get 7, but we're not guaranteed 7. Remember, we're only guaranteed all the numbers. Remember, the intermediate value theorem says I'm only guaranteed the numbers between -2 and 4. Between -2 and 4. 7 is not between -2 and 4. So that one would be false. 2. Oh, 2. Yeah. 7's not. But 2 is. 2 is. 2 is. I cannot go, if I start at -2 on the number line and try to go all the way to 4, or the other way around, depending on what you're looking at, you cannot go from 4 to -2 or -2 to 4, but without passing through 2. Seems pretty simple, right? Once you get it, right? -5. Is -5 between -2 and 4? No, -5 is not. If I have my number line with -2 and 4, -5 is not on that number line. Now that doesn't mean the function couldn't theoretically be that, but we're not guaranteed it by the theorem. The theorem's not going to guarantee that. How about 1? Yeah, 1 works, right? 1 is between. Now you don't have to draw the picture, right? You might be mysterious. Why did you draw the picture? It's kind of lame. Yeah, I know. I was a little slow as a kid, and that's how I did it. Is I said, okay, 1 is between -2 and 4, so that's true. Okay, that's one way they ask the question. The next way they'll ask this question is, what if they give you a whole bunch of data and they say, okay, it goes through all of these points on 0 to 5. What's the fewest times that it has to be 2? Now, I'm going to show you 2 ways to do this question. I'm going to show you the way I did it, and I'm going to show you the way that most people do it. Well, actually, let me show you the way most people do it, and then I'll show you the way I do it, okay? Because I think the way most people do it is better. But, it's always good to see different ways. Here's what you look at, okay? So, if I go from 1 to 2, the y values, this is the x and this is the f of x. If I go from 1 to 2, the y's go from -1 to 3. When I go from -1 to 3, I had to pass through 2, so that's the first time. When I go from 1 to 2, from x goes from 1 to 2, y goes from 3 to 5, or f goes from 3 to 5. No, if I go from 3 to 5, I am not guaranteed that it has to be 2, because 3 to 5 is just numbers between 3 and 5. Then the intermediate value theorem says that from 2 to 3, I went from f of 5, or f being 5 to f being 1. Yes, I cannot get from 5 to 1 without crossing 2. Then, can I go from 1 to -2? No. If I go from 1 down to -2, I'm not guaranteed. It may happen, but I'm not guaranteed that it's going to hit 2. And then, last but not least, from 4 to 5, it went, when f of 4 is -2, f of 5 is 6, So the F's went from -2 to 6. That does have to pass through 2. So we would say 3 times. Now I'll be honest with you, that's not necessarily how I would do the question. I literally do it this way, and this is just personal preference. It's going to sound kind of dumb, but this is the way I do it. 1, 2, 3, 4, 5. And I do f of 0 is -1. F of 1 is 3. F of 2 is 5. F of 3 is 1. F of 4 is -2. And 5, 6. So it goes up, down, and I connect them straight. And then I literally draw a line at 2. And I count the number of times it intersects. Now I'm going to do one more example, which is really just on continuity. Okay, this actually is on continuity. This kind of will be the last. This is the last of 1.8. 1.8. It's on continuity, and it's on the definition of continuity. Okay, and I'm going to end with this just so it's not too short of a video. So this one, and all 3 of these probably will appear on quizzes in the next few weeks. So, to be honest, I thought about not making the video, but then I realized, well, you know what? I'm going to probably give you all 3 of these questions in the next few weeks. So you may as well at least see what the questions might look like. Okay. If I tell you it's continuous, and I tell you f of 3 is 7, what do you know? And okay, this is what, I don't know what I know. This is what you know. We have a rule. If it's continuous, the limit as x approaches a of f of x equals f of a. So what you want to write down immediately upon seeing this, if you know this is true, then you automatically know the limit as x approaches 3 of f of x has to be 7. Because if it's continuous, then why am I doing this one right now? Because almost all of the homework you did is on discontinuous, right? Why is it discontinuous here? Why is it discontinuous here? Well, it turns out that they can actually ask you about, is it continuous, right? So this is one of the few questions that I've seen on the AP exam where they ask you, is it continuous? Because most times they ask you when it's not continuous, okay? So here's the deal. This is what it means to be continuous. This is what it means to be continuous for us. Since I know the limit has to equal the function value, if the function value is 7, then the limit at 3 has to be 7. So let's check. Now the question is, which of these is true? Okay. Which of these is true? I didn't write the directions down, but that's what it was. So if I put 6 in, I get f of 6 is 14. We don't know if that's true or not. We have no idea what f of 6 is. The only thing we know is f of 3. If this is not f of 3, we don't know anything about it. Now it may or may not be true, but we can't be guaranteed that it's true. It's not necessarily false, though. We just can't be guaranteed that it's true. Okay, if I approach 1, put the 1 in, you get f of 3. All right, that's groovy. Yay, we like that one. That one definitely has to be true. How about putting the 3 in here? F of 9 has to be 49. Again, if this isn't 3, it is automatically not something we know, because the only thing we know about this question is f of 3. Nowhere does it say f of 6 or f of 9 in here, so no, don't know anything about that. That doesn't mean it's not true, but it probably isn't, okay? And then the last one, f of 3, so I get f of 3 squared equals 49. Now remember what we know. F of 3 is 7. Oh, yeah, that's true. True. So, you guys, this is just a few examples of, well, 2 examples on the intermediate value theorem from 1.8, and then there's one on continuity. I like this because it kind of ends this section. That ends chapter 1, really. And then the next set of lessons, we're going to really start calculus. But to start calculus, remember, we have to really worry about dividing by 0 and this idea of discontinuity and all that. And so we're kind of setting some groundwork. But next week, we actually start to do the idea that Newton came up with, this idea that the velocity is distance divided by time, or what we call the slope of like the 2 points, slope of the line. And then what's weird is what we're trying to do is trying to find the slope not at 2 points, but at 1 point, right? So it gets kind of weird. Anyways, so this is the end of 1.8. Okay, bye-bye.